can't find this, just look up, but this is number 20 from lesson 4. This is tougher than I would ask you as a full written question on a test. I might feel okay giving it to you as a nasty on a take-home quiz because you can always do the corrections and learn from your mistakes. It says you're driving along a road at 80 kilometers per hour. I did the conversion. I divided by 3.6, so there's the 22.2 meters per second. When you see a moose 50 meters in front of your car, your reaction time is 0.4 seconds, and when you finally hit the brakes, your car accelerates at a rate of negative 6.4 meters per second squared. What's the negative telling me? Why is the acceleration negative? I'm slowing down, okay? Will your car stop in time to avoid the moose? This is worded very tricky because it says stop in time, but I'm telling you what we want to find is that. In fact, I'm going to write that down here. We want to solve for D. And if D is less than 50, the moose survives. If D is more than 50, the moose is dead. This is also the same physics that they would use if there's a road hazard and they want to calculate how far in front of the road hazard they need to put the warning sign so drivers have time to react. This is how you would calculate that distance as well. This is a really tricky question. It has two parts. Before you hit the brakes and after you hit the brakes. And so the first thing that I did is I'm going to divide this in two. This is before I hit the brakes. I chose to call that while I'm still coasting. This is after I hit the brakes. It's while I'm braking. What I'm going to do, again, I've done enough of these that I can see this. I wouldn't necessarily expect you to see this your first time around, but once you've seen it before, now it's part of your toolkit. What I'm going to do, Zainab, I'm going to find the distance I travel while coasting. I'll call that D with a subscripted C for coasting. I'm going to find the distance I'll travel while braking. I'm going to add them up. And if they're less than 50, the moose lives. Okay. By the way, these are subscripts. I see some of you writing VI like that. I'm not going to mark that wrong, but it is a subscript. It's VI. It's VF. The F is not on the same line. If you write VF, that's really technically V times F. F is frequency. V is velocity. It's something. So you want to be cautious. Get in the habit of making the subscripts actual subscripts. Alrighty. This 22.2, what's that? Well, that's before I've hit the brakes, so I'm pretty sure that's VI while I'm coasting. My reaction time is 0.4 seconds. That 0.4 seconds, is that the time it takes me to hit the brakes, or is that after I've hit the brakes? What do you think? My reaction time is 0.4 seconds. So I see the moose. Hey, moose! That took 0.4 seconds. Have I hit the brakes yet? So it's still while I'm coasting. T is 0.4. Now I hit the brakes. A is negative 6.4. That's while braking. And will my car what? Stop. VF is 0, Kobe. You gonna make it? You're looking like that angle is getting lower and lower every time I look at you. You gonna make it? Okay. Problem, Kobe. How many things do I know in this area? 2. I need 3 things to find the 4th. Faith, how many things do I know here? 2. I need 3 things to find the 4th. So now I need to get a little bit clever. Before I hit the brakes, while I'm coasting, I'm neither speeding up nor slowing down. I'm going at a constant velocity. If that's the case, what's my acceleration exactly as a number? So I need to realize that on this side, A is 0. Now I can find an equation that's got a D, a VI, a T, and an A in it. It's this one. D equals VIT plus a half AT squared. But this time, that vanishes. We've done this one before where the VIT vanished when VI was 0. In this case, A is 0, which actually makes it a nice, easy equation. It's just going to be VI, 22.2, times 0.4. This is the distance I travel before I hit the brakes. If I quickly crunch that, I get 22.2 times 0.4. I travel 8.88 meters. D coasting is 8.88 meters. That's before I hit the brakes. Now I hit the brakes. Leo, I still have the same problem. I have two things. I need three things to find the fourth. So let's pretend here's a picture of me driving. Here's the moose. I can't draw. Right there is where I hit the brakes. How fast was I going exactly right at the beginning of this question? Anyone, how fast am I going at the beginning of this question? Oh, I got to scroll up a little bit. How fast am I going? How fast am I going right here? Because I haven't hit the brakes yet. Still. How about right here? How about right here? How fast am I going right when I hit the brakes? What's my initial velocity right when I hit the brake? That's the next aha moment. I need to realize actually VI is still 22.2 right at the beginning of hitting the brakes because I haven't started to slow down yet. It's right when I hit the brakes. And now I have three things. I can find a fourth. This time I think it's going to be VF squared equals VI squared plus 2AD. I think it's going to be D equals VF squared minus VI squared all over 2D. It's going to be 0 squared minus 22.2 squared all over 2 times negative 6.4. If I crunch that, I get 0 squared minus 22.2 squared, close bracket, divided by 2 times negative 6.4. I get 38.5 meters if I didn't make a typo. I don't think I did. That's my braking distance. What's my total distance before I come to a stop? 8.88 plus 38.5. Which is, sorry, does the moose survive? Barely. Barely. And then part B, when it's raining and you couldn't accelerate backwards as fast, there you'll find when you solve for it, it's going to be the same thing with different numbers. You'll find you hit the moose. 47.4 meters. So that's, again, a nice application. You would also use that to say, okay, if this is a sign and I need to want to have drivers have time to react and slow down, and I know what the acceleration they can pull on this road is, that's how far in front of the road hazard I need to put the sign. And then you probably give them a bit more time because drivers are dumb. So you put it a little further forward. Why don't you want to put it like way forward? Because they'll see the sign and then their attention will wander and they'll forget about it because it hasn't happened yet. Or they'll think, oh, I guess the hazard wasn't there. So you want to find that balance. You'll figure this all out when you start to drive. So I did promise to do number 20, so that's number 20 if you're stuck with it. Number 19 is really, really similar, and number 19, there is a YouTube solution showing all your steps to do that one that I put on YouTube, if you want to try that. Is that okay, Maddie? Yeah? Okay. Give me 1 second. Pause the video. Quick look at the take-home quiz, quiz number 2. This is all from the stuff we did in lesson 4 where we started doing word problems. So number 1, it looks like it wants you to find the acceleration. You know what? I'd probably underline the phrase at rest. That's kind of an important phrase that tells you something. And then find the final speed. I think you're actually going to find the final velocity because I think there might be a directional component. Number 2, looks like it wants you to find the acceleration, the distance traveled. Number 3, how far. 3B, how long. Turn the page or next page over. I think, is it next page over? Number 4, find acceleration. Number 5, find the velocity. Number 6, here's the jet airliner question. So number 5, there's the jet airliner question. Number 6, here is the RCMP car crash question. We did one like this. So it's not stuff you haven't seen before. I'm going to try and give you some time at the end of class today to work on it. But for now, let's get to lesson 6, Mr. Dueck. Pause the video again. Lesson 6, free fall. Arfan, you going to put that away, please? Thank you. Did I go over lesson 4, number 20? I can delete that. But first, I promised you this back when we did G's. We looked at G's a couple of days ago. How big is 1G? 9.8 if you want to make it downwards because it's free fall negative, but as a magnitude 9.8. I did promise you we would look at the biggest G's survived on record. It's David Purley. In 1977, in Northamptonshire, England, David Purley's race car crashed and his speed dropped from 174 kilometers in 0.66 meters. 174 kilometers, is that fairly fast? Kilometers per hour, is that fairly fast? 0.66 meters, he stopped dead in about this distance, right? Because that's a whole meter, so about that. That's some pretty serious acceleration. He had 29 fractures, 6 dislocations. His heart stopped 6 times, but he did survive and make a mostly full recovery. Oh, Ethan, what's this want me to find? How many what? We can't. Well, we can't. What do we have to find first before we can find G's? Who remembers? So let's write down A equals question mark. What's that 174 kilometers per hour? First of all, why don't I like that 174 kilometers per hour? Yeah, Peyton, I saw him go, roll his eyes. He's getting his calculator out. I think we're going to have to divide by 3.6. Yes, Peyton, is that correct? I'm going from memory. I think it's divided by 3.6. So 48.3. I'm going to go like this. I'm going to cross out the 174 and I'm going to write above it 48.3 meters per second. Now that I've converted it, what is that? Time? No. What is that? VI? Okay. What's that 0.66? What are the units next to it? This is why it's worth memorizing what units go with what. It takes an effort, but not a big effort. That's the displacement. That's 2 things. I need 3 things to find a 4th. What else do I know because it's a car crash? I'm looking for an equation that's got an A, a VI, a D, and a VF in it. There is one. Leo, which one? He's right. It's the squared one. So now today I'm going to say don't write that down. You can if you want to, but I'm going to say, is it on your green sheet? Well, then stare at it. Don't copy it out twice. Stare at it. Get the A by itself for me, Leo. What's going to drop down like a domino? Then what? The VI what? Yes, don't forget the squared. And then what? Yes. Your goal is to see if you can get maybe even a little more comfortable than Leo just was in the next couple of days, being able to glance at the equation and rewrite it in your head. And again, if you can't, if you got to write more steps out, I'm okay with that. What I am saying, Faith, is if you can, knock yourself out, but not literally. It's going to be 0 squared minus, and I'm just going to use my answer button right there since it's sitting on my calculator. You can type 48.3, but why wouldn't I use the whole answer button? Divided by 2 times 0.66. I have to say to myself, is this a fraction? Yes, it is. Is there more than one thing on the top? I have to put brackets around the top. And I have to put brackets around the bottom. Man, what'd you get? That's my way of saying, I don't think you're on your calculator right now, and I've told you from day one. I'll call you on it. You back with me? Good. Smiling sheepishly. Yeah. Leo, what'd you get? I got negative. You're going to get a negative. Why negative? He's very much slowing down. I got negative 1,770. That's not G's. That's the acceleration. What are the units for acceleration? So I'm going to write negative 1,770 meters per second squared. Ethan, coming all the way back to you, how do I turn an acceleration into G's? How big is 1G? Divide by what? Okay. And I didn't put that on your green sheet. I thought about it. I'm kind of hoping you'll internalize it because it makes sense. Oh, if 1G is 9.8, how many G's fit into the acceleration? You're going to divide. So G's, I think Afan already crunched the number because I saw his eyebrows raise. It's going to be my answer button divided by 9.8. How many G's did he pull and survive? It's pretty high. Afan, what'd you get? You know what? That's a 5. I'm going to give him, he's earned the roundup. Negative 181, I'm going to say. The negative, he's slowing down, but he pulled 181 G's. To put that into perspective, that means he had 180 of him dogpiling on himself. Well, of course, because he had 6 heart stoppages, 29 fractures, 3 dislocations. This was not a walk in the park. Okay? I just did some research this morning about 12 years ago. I haven't updated this for a little bit. About 12 years ago, a race car driver survived 214 G's. I got the video, but that was mostly spinning, but it was a pretty intense wreck. Apparently, he spun fast enough that one of his vertebrae collapsed on another vertebrae. They just pancaked, and his leg nerves snapped and went snapping up into his abdomen. So food for thought. You don't want to be in a big car accident. Okay. Race car driving is very, very dangerous. So it's not a profession I recommend you go into. But there's good physics in it. Let's look at freefall. When an object is falling through the air, we say that it is in freefall. Now, it says free fall, but really all it means is the only force acting on it is gravity. Everybody look up, sorry for those of you on YouTube. On the way up, the tennis ball is in free fall. On the way down, the tennis ball was in free fall, because in both situations, the only force acting on it was gravity. So I know it says free fall. You can be on the way up and still be in free fall if nothing's touching you. If the only force acting on you is gravity, we're ignoring air resistance. In free fall, the acceleration is always, well, it's 1G, but what's that as a magnitude? And now we're going to incorporate a direction. We are going to say things accelerate down. How can I show down mathematically without writing out the word down? So we're going to say the acceleration is always negative 9.8 meters per second squared. In other words, if I say to you that we're dropping an object or throwing an object or an object is in free fall, I won't tell you A in the question. You can assume, Clara, that the acceleration is going to be equal to negative 9.8. I'm not going to tell you that. That changes on other places like the moon. G on the moon is about negative 1.6. If I put you on a different planet, I will give you the acceleration in the question, Peyton. You don't need to memorize other planets. But the one on the Earth, even though I put it on your formula sheet, it's a pretty good indicator to me that you haven't been doing any of the homework. If I say to a kid, well, what's the acceleration due to gravity? And if they have to look it up, then I know they haven't been doing any of the homework. Okay? Put your pencils down and look up. This is from Norway, I think. This is some base jumping, which is when you don't jump out of an airplane. Instead, you jump from a cliff. And this is interesting. So you'll be able to see free fall. What's he accelerating at? Negative 9.8 if we want to include down. We're going to ignore air resistance. Now, I have jumped out of an airplane, and you will see a video of that later. I will say these guys are doing things that I don't know if I could bring myself to do. I think it's this next one, Lucas. Yeah. How many of you have ever done a trust fall where they ask you to fall backwards into somebody else's arms and they catch? Okay. I've done that. I gotta be honest. I don't know if I could step backwards off of a cliff not looking down, even though I trusted my parachute. I got to give him full props. there's a lot built into us that if you're standing on a cliff, every part of your body does not want to let you step backwards and jump. Lucas, you're with me, right? Also, it looks like he's getting close to those rocks. Clearly they've practiced. And for them, air resistance is making a difference. They can use that to control themselves a bit. We're pretending there is no air resistance to make our math easy. The other one that he's about to do. Okay. Again, I have jumped out of an airplane. I don't know if in free fall I could have turned my back to the ground and just casually, yeah, whatever. If I could have done that, but so full credit to them. They've clearly had lots of practice.
Slang when you notice the stripes, the dirt in your prize. Hope it's right when you die, old and bony. Dawn breaks like a bolt through the hall. Never should.
So they're in free fall. What are they accelerating at? If we ignore air resistance for the entire time, they're always accelerating at negative 9.8 meters per second squared. There, eventually towards the end, there was some air resistance, which is how they can maneuver around. Peyton, we're going to pretend that doesn't happen because the math is just yucky. Okay. Example 2, I like example 2, I like example 2. In fact, really, I like pretty much all the questions here. Let's look at some free fall questions. Ball is dropped from a cliff. Everybody underline the word dropped, please. If we drop something, yeah, it's going to go down, Captain Obvious, I got that. But if we drop something, what's VI as a number exactly? If I drop something, what's my initial velocity? So from now on, if you see this word, here's another physics vocabulary, you can assume VI is 0. I won't tell you that in the question. I'll say dropped. It hits the ground 10.6 seconds later. Oh, here it is. It says note dropped means we know that VI equals 0. I was going, I should have written that in my notes somewhere. I did. I just need to look down one line. Okay. Mason, what's A asking me to find? How high? Which of my 5 physics concepts is that? Time? No. What's it asking me to find as a physics concept? Yeah, I heard someone whisper it. Did you pick it up? And I think it's going to be a displacement. And I'll convince you of why that is in a second. But I agree with you, Mason. I am going to write D equals question mark. I'm going to put the vector symbol because we actually are going to get a displacement. You'll see how in a second. Mason, what did we just say VI was? What's that 10.6? What are the units next to that 10.6? So, yep. That's only 2 things. We're in free fall. What's the acceleration? I'm not going to tell you this anymore. Yeah. Mason, I'm looking for an equation that's got a D, a VI, a T, and an A in it. There is one. Which one? And read it to me, please. Why'd you waste my time? You're correct. But what's VI in this specific example? So what's VIT going to be in this specific example? What's 0 times T? So what you could have, and this is not wrong, what you read is correct, but if you start to notice that you have some zeros, if you want to, Mason, you could just write D equals 0.5 AT squared. Or the other way I've written it is D equals AT squared over 2. You could have skipped writing the VIT to man it because it's 0. I will not make you do that, but you've heard me use the phrase lazy but organized. Mason, I'm going to say, pay attention and be lazy if you can. Let's crunch the number. Oh, what do we need to get by itself? What has a question mark next to it? So what do we need to get by itself? Same answer. What's already by itself? Same answer. Woohoo! Okay. Were you overcomplicating that? Yes. I'll remind myself that I'm going to get a vector answer. Which one do you want to use, the 0.5 or the over 2? I don't care, pick. Okay. So I'm going to crunch our numbers. D is going to be 0.5 times negative 9.8 times 10.6. Don't forget the squared. What do you get? Oh yeah, now Tamana, all of you want to be also, once you've written that down, typing on your calculator, right? Point 0.5 times negative 9.8 times 10.6 squared. I got negative 550.564, or am I wrong? Yeah? What's the negative telling me? It's a displacement. At the end of this, are we above or below from where we started? And the universe is telling me that. Okay, the universe is saying, dude, you started at rest and you accelerated down, you're going to end up below. That's why when you said distance, I said, we're going to get a displacement, Mason. That's the negative telling us we did this right. So I'm going to write, if I go to 3 sig figs, is that 0 going to stay as 0 or become a 1? I'm going to write negative 551 meters. Now that's the displacement. Technically, height is a scalar, but I haven't taught you that. So I'm going to say the height is positive 551 meters, just because when you talk about a cliff, you don't say a cliff is negative 551 meters high, but I will take either answer. I will take the positive or the negative one in this case, because we haven't done the unit where we start talking about height as a scalar yet. I'm sneaking it in right now. Okay? B. What's that, everybody? I should ask Dom questions while he's trying to shovel food into his face? Okay. Dom, what's B asking me to find? Yeah, what's it asking me to find is a physics concept. Definitely a velocity. Which one? VF. Isn't VF 0 when you hit the ground? No. It's 0 after you hit the ground. But when you hit the ground, the reason I know it's not 0 is if I do a belly flop onto the cement, it's going to hurt. And you can test that for me if you want. If you do a belly flop and land on the cement and it doesn't hurt, then I'll accept that maybe it was 0. It's 0 after we hit the ground. So I agree with you. I'm going to write Zainab VF equals. What else can I use? Can I still say VI was 0? Was it still dropped? Yes. Is it still falling for 10.6 seconds? I think so. Oh, I said falling. What's A? Mr. Dueck? Yes, Dom. Could I also use the negative 550? Believe it or not, you could. The only issue is if I got this wrong and I use it, I'm going to get this wrong. So Dom, now that you've taken a huge bite, I'm looking for an equation that's got a VF, a VI, a T, and an A in it. Which one? If you ever want to have fun, by the way, if you go out for dinner with a friend and you're having a conversation, I'm serious, try this. Every time they take a bite, ask them a question. They won't notice that you're doing it on purpose, but they'll feel so dumb after an hour straight of that. And you, what, you guys don't think of those things? Oh, come on, you gotta have a little fun in life, people. I don't know, what is the first one? Read it to me. Why'd you waste my time? What's VI? So again, I'm not going to say you have to. I'm going to encourage you. Spot the shortcuts. We can, in this case, just say VF equals AT. Yay. It's going to be negative 9.8 times 10.6. It's not wrong to put the 0 plus, and I will not take marks off if you do, but don't think like you have to. Oh, almost knocked that over. That would have been a disaster. What'd you get, Dom? Yeah! Yes, you calculated. Yes! Wow. YouTube's going, who is this Dom guy? I don't know. He's carbon up, but that carb's got to get to his brain now. What's the negative telling me? What direction are we traveling when we hit the ground? Down. So I'm okay with that. What'd you get? Negative 9.8 times 10.6. I'm going to go to 3 sig figs, so I'm not going to say negative 103.88. You could, but I'm going to say negative 100 and what? 4, I think I will. Units. Oh, I should have waited till he took a bite. Units. It's a velocity. Yep. So if we're talking free fall, I can give you some information and saying, tell me the height of the cliff, tell me how fast we hit the ground. Ooh, C. What's the velocity of the cannonball after 3.6 seconds? Faith, what's this question asking me to find? Yep. Is VI still 0? I think it's still dropped. Is T still 10.6? No, so let's adjust our data. 3.6. Over in free fall, what's the acceleration? Which equation? Why'd you waste my time? I think VF equals AT. Yeah, VI plus AT, but AT. It's going to be 3.6. Well, not 3.6. A is negative 9.8. Not that it matters the order, but let's write it the same way I wrote it. Negative 9.8 times 3.6. How fast will it be going? I don't know why I put that in brackets. Faith, did you get, what'd you get? Yep. Meters per second. What's the negative telling me? It's going down. Also, I could have predicted, since in 3.6 seconds, it's not going to be going as fast magnitude-wise, I knew the magnitude would be less than 104. So if I'd gotten negative 353, I'd be going, I think I made a typo somewhere, because I don't think it sped up and then slowed down. Right? D. Ooh. How far has the ball fallen? Gila, what's D asking me to find? And by the way, it's going to be a displacement because I think we're falling. We're ending up below from where we started. I'm going to bet you we're going to get a negative answer here. So it's technically a displacement. I'm not marking either word right or wrong. I'm saying when I get a negative, I won't panic. I'll probably relax and say, yeah, that makes sense. So here's your first shortcut. Write that, D equals question mark. Gila, what was the time in part C? What was the time in part D? I'm not going to relist all my data. It's sitting in part C. So find me an equation that has a D, a VI, a T, and an A in it. There is one. I agree. Ah, I was crossing my fingers saying, is she going to read the VIT? Yeah, we can go straight to D equals 0.5 AT squared. It's going to be D equals 0.5 times negative 9.8 times 3.6. Don't forget the squared. And then don't turn the page yet. Show you another handy trick. Tell me what you get, Gila. 0.5 times negative 9. Let's clear, Mr. Dueck. 0.5 times negative 9.8 times 3.6. Don't forget the squared. Did you say negative 63.5? I agree. Gila, let's suppose this was a test question and you finish early. Here's what else would have worked. I could have used my VF value from here. I could have gone get the D by itself. I could have hustled off to my calculator and said, you know what? It's going to be negative 35.3 squared minus 0 squared, close bracket, divided by 2 times negative 9.8. And I get pretty much the same answer. Not quite, because I rounded off a little bit, but the fact that I got the same answer means I must have done both of these right. This test, you've now learned enough physics that for a lot of the part B or part C of a question, you'll have 2 or 3 ways to get the same answer. Before you hand your test in to check your answers, try solving for it a different way. And if you get the same answer both ways, everything above it's got to be right. So this is a bit of a way you can check your answers. Okay. Negative 63.5. Hey, they match. Yay. Now turn the page. Example 3. A ball was thrown straight up with a velocity of 29 meters per second, and then I had to add something in brackets because I had somebody last year who was really fussy. They said, let's assume we're laying on our stomach on the ground when we throw the ball, so the initial height is 0. Otherwise, we would need to know how tall the person was throwing the ball from. And I said, that's a good point. It was worth discussing. So if you ever see me launch something, assume we're launching it from the ground unless the question says different. Okay. Maddie, what does A want me to find? Good, because how long is that vague one that can be distance or time, depending on the context? And yeah, I'm pretty sure this one is time. We're going to finish with this example, I think. Example 3, we'll do A, B, C, D, and E. And then the rest of the class will be yours to work on the quiz and other homework. What's that 29? Yeah, sorry? Is that how fast it's going at the end, or is that how fast it's going at the beginning? I think it's VI. That's the launch. It's in free fall, even on the way up. Once it's launched, what's the only force acting on it? Gravity. So what's it accelerating at? It's moving up. On the way up, is it speeding up or slowing down on the way up? Be obvious. You've thrown stuff. So yeah, it is accelerating down. It is negative, so that still works. Okay. Problem, that's 2 things. I need 3 things to find the 4th. I know one more thing at the top. Everyone look up. Everyone look up. Yeah, Dom, you too, look up. Watch, 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 watch. At the top, for a split second, what was the speed? What was the velocity? For a split second, it does come to a stop. And so VF is not 0 on the ground. Do a belly flop onto the cement. It will hurt. VF at the top for a split second will be 0. Maddie, I'm looking for an equation that's got a T, a VI, an A, and a VF in it. There is one. VF equals VI plus AT. Get the T by itself, please. What's my new equation? Yep, 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 yep. It's going to be 0 minus 29 all over negative 9.8. I started to get nervous because time is always positive. The top was negative. Oh, wait a minute. The bottom's negative as well. What's a negative divided by a negative? I'm positive. So how long will it take for the ball to reach the top of its height? 0 minus 29, close bracket, divided by negative 9.8. Good yawn, Mason. Maddie, how will I round that to 3 sig figs? 2 point... What? Yep. Units, time. Yep. Elijah, what's B want me to find? Sorry, someone made a noise. What physics concept is height asking me to find? Displacement. Yeah. Are we ending up above or below from where we started in this question? I think I'm going to get a positive displacement. If I get a negative displacement here, I'll get nervous because the ball is up there at its maximum height. So that's the difference between distance and displacement and scalars and vectors. I kind of told you a few days ago that when we do free fall, direction is going to start to matter more and mean more. So I'm going to go D equals question mark. Is VI still 0? Yes, I'm not going to rewrite it. Is A still negative 9.8? Yes, I'm not going to rewrite it. Oh, are we still coming to a stop at the top for a split second? I'm not going to rewrite it. I'm looking for an equation, Elijah, that has a D, a VI, and A, and a VF in it. There is one. The squared one, yeah? Get the D by itself, please. Yeah. Now, VF is 0, so you could have just said negative VI squared on the top, but because the VF was by itself, I didn't mind you dropping it down, because that's always been our drop it down like a domino move first. So yeah, it is going to be 0 squared minus 29 squared all over 2 times negative, Mr. Dueck, 9.8. What do you get? So we can now figure out if we launch a rocket or a projectile. If you give me the initial launch speed, I can tell you how high it's going to go, ignoring air resistance. And if we make the rocket pretty aerodynamic, Mason, air resistance will make a big difference anyways. Let's see. 0 squared minus 29 squared, close off the top, divided by 2 times negative 9.8. Close off the bottom. I got 42.9. Anyone else? Yep, and positive, which makes sense. I'm ending up above from where I started. Units, it's a displacement. Meters. What's the impact of the velocity of the ball right when it hits the ground? I'm going to give you a hint. You already know the answer. It's also why I didn't leave you any space to show work for part C. You'll notice only a tiny bit of room. Tristan, what goes up must come. Are we starting and ending on the ground in this question? We are. There's no cliff. What's my impact velocity? If what goes up must come down. Sorry? Do you see it, anybody? Direction. Negative 29. Yep. So another thing worth putting in our back pocket that I won't tell you again, if you're starting and ending on the ground, you're going to hit the ground the same velocity you left the ground, but negative. Not from a cliff, because from a cliff, it's going to continue to fall further. It's going to hit the ground harder. Yeah. 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 So we have to look at what's causing the ball to bounce. The ball is bouncing through what's called a transfer of energy, and that transfer of energy isn't perfect. There's a tiny bit of energy lost when the ball impacts and deforms. There's energy lost to heat, which doesn't leave it as much energy to bounce back to its original height. And depending on what you make the ball out of, you can change the efficiency of the ball, but they'll never be 100% efficient. It's a good question. We'll visit that. The last unit we'll do this year is work and energy. Yep, it's a really good question. Did I leave you some space to show work for part D? Okay, fine. What's D want me to find? Carly? Yep. And again, you'll notice A was how long? And D is how long. And this is why I said that phrase is vague, but you can figure out from the context whether they want you to find a time or a distance. Okay. A is negative 9.8. I agree. VI is still 29. Oh, what did I just find in part C? Looking for an equation. It's got a T, an A, a VI, and a VF in it. There is one. Get the t by itself, please. Negative 29 minus 29 all over negative 9.8. I got 5.92, yes? Seconds. What if I wanted to find, oh no, we did find the time to top, didn't we? The other thing we could have done is we could have taken this 2.96 and doubled it. Because what goes up must come. If we're starting and ending on the same place, the trip up and the trip down will be the same if we ignore air resistance. So I could have taken that times 2, or if I hadn't done that, I can say, wait a minute, I know VI, I know VF. That works. Last question, and then we're going to press pause for the day. What's the displacement of the ball once it hits the ground? Ethan, what? How is it 0? How high was it when it started? 0. How high is it when it finishes? 0. Displacement is your change in position. Did your position change? That's the difference between displacement and distance. The displacement is 0. Well done. Your homework is the take-home quiz. We're going to pause here. By the way, we dropped an object from a cliff. Then we threw an object from the ground. Example 4, we're going to throw an object from a cliff. We're going to combine them, okay? And then we're just kind of mix and match all that we can find. If you want to get a head start, I am going to be assigning a lot of these questions. Questions you can do already. I think you can try number 1. You want to do these on a separate piece of paper? You can try number 2. You can try number 3. Put a star next to number 4. You can try number 4. I haven't quite talked about number 4 yet. 5 is good. 6 is good. Number 6 says an empty propane tank is accidentally dropped from a hot air balloon and it hits the ground with a speed of 148.3. I can't use that speed. What do I need to do? What direction was it traveling when it hit the ground? Be obvious. What direction was it traveling when it hit the ground? You'll have to make that one negative because it was traveling down. What was VI? Oh, dropped. You should underline the word dropped. VI was 0. So lots of information we can pull out of these. I'm going to assign more later, but take home quiz. And if you haven't finished lesson 5.4 in the lab, okay, let me hit pause on the video.